Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about Rayleigh density function. The Rayleigh density function is a special relation to Gaussian density function. In my previous videos, we have already discussed Gaussian distribution and Gaussian density function. So the probability density function of the Gaussian random variable is small fx of x is equal 1 by square root of 2 pi sigma square e power minus of x minus m whole square by 2 sigma square. In this equation, m is the mean value of the random variable, sigma square is the variance of the random variable. So now here the Rayleigh density function is a special relation to Gaussian density function. Consider two Gaussian random variables capital X and capital Y with zero mean value and same variance sigma square. So using this equation with zero mean value and same variance, the probability density function of random variable x is in this equation substitute m is equal to 0. We get the density function of the random variable x is 1 by square root of 2 pi sigma square e power minus x square by 2 sigma square, and density function of the random variable y is fy of y is equal 1 by square root of 2 pi sigma square e power minus y square by 2 sigma square. So we know that, let us consider x is equal to r cos theta and y is equal to r sin theta for theta is equal to 0 to 2 pi and small r is equal to 0 to infinity. Then dx dy is equal to r dr d theta. So now here x is equal to r cos theta and y is equal to r sin theta. Then x square plus y square is equal to r square. So we have started with two random variables, capital X and capital Y are the two old random variables, and consider two new random variables r and theta. So we know that the relation between the new random variables and old random variables joint probability density function is f of r comma theta is equal f of x comma y into determinant of j bar of x comma y. F of r comma theta is the joint probability density function of new random variables. F of x comma y is the joint probability density function of old random variables x and y, where j bar of x comma y is dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. But x is equal to r cos theta and y is equal to r sin theta. Find out dou x differentiating x is equal to r cos theta with respect to r and with respect to theta, we get dou x by dou r is cos theta, dou x by dou theta is minus r sin theta. So, but y is equal to r sin theta, differentiating y is equal to r sin theta with respect to r and with respect to theta. So, dou y by dou r is sin theta, dou y by dou theta is r cos theta. So, reducing, simplifying this RHS term of the determinant, cos theta into r cos theta minus r sin theta into sin theta. So cos theta into cos theta cos square theta minus into minus plus sin theta into sin theta sin square theta. So now here on both the terms r is the common, r into cos square theta plus sin square theta. So cos square theta plus sin square theta value is 1. So the remaining RHS term is 1. So j bar of x comma y is r, and substitute this value into this equation. Therefore f of r comma theta is equal r into f of x comma y. Since the random variables x and y are independent random variables, the joint probability density function is equal product of their individual density function. So that is f of r comma theta is equal r into f of x into f of y. So now here this is the f of x value and this is the f of x value and this is f of y value, and substitute this f of x and f of y values into this equation. We get f of r comma theta is equal r into fx of x is 1 by square root of 2 pi sigma square e power minus x square by 2 sigma square. Fy of y is 1 by square root of 2 pi sigma square into e power minus y square by 2 sigma square. So 1 by square root of 2 pi sigma square into 1 by square root of 2 pi sigma square is 1 by 2 pi sigma square. So that is f of r comma theta is equal r by 2 pi sigma square. This exponential term into this exponential term is written as e power minus of x square plus y square by 2 sigma square. But x is equal to r cos theta and y is equal to r sin theta, then x square plus y square is r square. Substitute x square plus y square is equal to r square into here. We get f of r comma theta is equal r by 2 pi sigma square into e power minus r square by 2 sigma square. So this is the joint probability density function of new random variables. Next, we can determine marginal density function of the random variable r. So we know that the marginal probability density function of the random variable r is f of r is equal integral 0 to 2 pi f of r comma theta d theta. So the value of f of r comma theta is already calculated and substitute that value into here. We get f of r is equal integral 0 to 2 pi r by 2 pi sigma square e power minus r square by 2 sigma square into d theta. So now here the integration is with respect to theta. So this term is constant, that is written before integration. We get f of r is equal r by 2 pi sigma square e power minus r square by 2 sigma square into integral 0 to 2 pi 1 d theta. Integral 1 d theta is theta over 0 to 2 pi. Now substitute upper value of theta and lower value of theta. We get the marginal density function of the random variable r is f of r is equal r by sigma square into e power minus r square by 2 sigma square for r is equal to 0 to infinity. So this equation is called as Rayleigh density function of the random variable. So differentiating this Rayleigh density function with respect to r and equating that value equal to 0. So that is dou f of r by dou r is equal to 0. Substitute f of r value into here. Dou by dou r into r by sigma square e power minus r square by 2 sigma square is equal to 0. So now we are applying the derivative of uv concept. Derivative of uv is u dv plus v du. So 1 by sigma square into r into dv. So e power minus r square by 2 sigma square differentiation is e power minus r square by 2 sigma square into minus 2r by 2 sigma square plus v into du. du is equal to 1. R differentiation is 1 is equal to 0. Multiplying this 1 by sigma square within the bracket term, we have minus r square by sigma power 4 e power minus r square by 2 sigma square plus 1 by sigma square into e power minus r square by 2 sigma square is equal to 0. So this term is going to the RHS side. We have minus r square by sigma power 4 e power minus r square by 2 sigma square is equal minus 1 by sigma square into e power minus r square by 2 sigma square. On both sides, e power minus r square by 2 sigma square is cancelled. We get r square by sigma square is equal to 1. So which is equal to r square by r square is equal to sigma square. So square is cancelled on both sides. We get r is equal to sigma. So Rayleigh density function is having its peak value at r is equal to sigma, and its peak value is, so in the equation of Rayleigh density function, substitute r is equal to sigma, we get peak value of the Rayleigh density function. And this is the equation of the Rayleigh density function. So here in this equation, substitute r is equal to sigma, we get f of r is equal to sigma here. Sigma by sigma square into e power minus sigma square by 2 sigma square. And reducing RHS term of this equation, we get the Rayleigh density function of the peak value is f of r is equal 1 by sigma into square root of e. So this is the peak value. And this is the graphical representation of the Rayleigh density function of the random variable. Next, we can determine the corresponding cumulative distribution function. So we know that the distribution function is integral of the density function, that is capital Fx of x is equal integral minus infinity to x fx of x dx. So similarly, capital F of r is equal integral minus infinity to r f of r into dr. Now here f of r is the Rayleigh density function that is already calculated. That is value substituted here. We get capital F of r is equal integral 0 to r integral 0 to r. Now here the r range is from 0 to infinity. Now here we can determine cumulative distribution function. For r is equal to 0 to infinity, the starting value is 0 and the final value is as it is same. So f of r is equal integral 0 to r by sigma square into e power minus r square by 2 sigma square into dr. Now here let t is equal to r square by 2 sigma square. Differentiate with respect to r. 2r dr is equal to sigma square into dt. On both sides 2 is the cancel. R by sigma square dr is equal to dt. Applying these considerations into this equation. Okay. So now here the ranges of the r is 0 to small r. Now here we are considering t is equal to r square by 2 sigma square. In this consideration substitute r is equal to 0 to r, then we can determine ranges of the t. If r is equal to 0, then t is equal to 0. If r is equal to r, then t is equal to r square by 2 sigma square. The ranges of the t are 0 to r square by 2 sigma square. Applying all these considerations into this equation, we get capital F of r is equal integral 0 to r square by 2 sigma square into e power minus t dt. So integral e power minus t dt is minus e power minus t by minus 1 over 0 to r square by 2 sigma square. Now substitute upper value of t and lower value of t. We get f of r is equal minus of upper value of t is e power minus of r square by 2 sigma square minus lower value of t is 0 e power minus 0. E power minus 0 value is 1. Multiplying minus within the bracket term, we get f of r is equal 1 minus e power minus r square by 2 sigma square for r greater than or equal to 0. So this is the corresponding cumulative distribution function of the random variable. So Rayleigh density function is used to represent the envelope of narrowband noise which is used in the noise analysis of various communication system. So this is the concept of Rayleigh distribution function and Rayleigh density function of the random variable.